Pasaloso. You know? Game finished? Like going on, sir? What is go? Still? Nice. Once you drop a little 2 points. Good to go. All right, so let's take a look at where we stopped last day in vectors. In vectors. Right, so as a quick review, we started vectors last day. We learned to represent vectors in 3 dimensions, I, J, K. Right, we looked at magnitude of a vector, unit vector, equality of vectors, addition and subtraction of vectors. We also looked at how to multiply vectors by a scalar and by themselves. We looked at displacement vectors and we looked at angle between 2 vectors. That's okay? That's what we did so far. Right, everything here is supposed to be from CSEC, it just we add on a 3rd dimension. Right, now we're going to something new. It's called the vector equation of a line. All right, so I just want to show you where all this came from. Right, hold on. So I want to show you where all this vector equation of a line came from. All right, so catch out there. Catch out there, right? I'll give him a pen a little time to charge. But you see the blue line there? The blue line, of course, is a line, right? What we're trying to get is the vector equation of that blue line, right? So to get it, we're trying to get a direction vector parallel to it that we'll call P, and we want a vector on the line. So I'm going to explain all that now, right? Just do a quick little sketch. As okay, Nathaniel, we now start. The audio, I wouldn't be able to hear, right? So you had to type, right? We now start. I'll wait on bear on them all the time. Oh, sorry. Sorry, I forgot to call you. Sorry, I forget to call you. Right? Make it. All right, done all do one more. All right, done. See you. All right. It's not up to action. You want to do one more? Call it good. One more. Yeah. Right, for those who now join, we're trying to find the equation of that blue line, right? Trying to get the vector equation, then we're going to get the Cartesian and then parameter of that blue line. Nice and easy stuff. We have 2 more things to do in this module. We have vector equation of a line and vector equation of a plane. All right? So that will be it for module 2. Use the same labeling, right? Right, I wanted to use the same labeling. So if you look at it there, the blue line is we're trying to find the vector equation of that, right? There's a vector parallel to it called P, right? That's the vector parallel to the line L. There's a point on the line called A. R is any random value XY, right? Use the same labeling, right? The position vector OA is small a. The position vector of OR is small r, right? And then we're going to build everything up from right there. Andy, we come. Yeah, I'm gonna join back just on the time. All right, so watch this here. So I'm going to go through the explanation here. What has happened? What are we trying to come up with? So let's say I gave you something like this. I gave you an equation of a line L, and I want to get the vector equation of that line. There are a few things that we need. We need something called a direction vector, which we call in P, right? We need a point on the line. We need a point on the line. Let's call that point A. And then we have any random point on the line. Let's call that R. All right. The position vector to A, we call it small a. Position vector to R, we call it small r. Right? We're going to use this here now to find an equation for the vector equation of that line L. All right. So AR, if we use direction vectors, what's the alternate route from A to R? A to O, O to R, right? So that'll be A to O plus O to R. That's okay? Well, what is A to O? A to O is small a, right? But you're going against the arrow. So that'll be minus A. Are you okay with that? And then O to R. That's small r. Are you okay with that? So if I made R the subject of the formula, right? Right? R is basically any position vector along L, right? R is equal to AR plus A. Are you okay with that? Now, since AR is parallel to B, what does that mean? It means that AR parallel vectors are what? What we know about parallel vectors? If two vectors are parallel, they are multiples of each other, right? So therefore, AR is some constant lambda by B. Are you okay with that? AR is some multiple of B. So if I substitute now, right? If I substitute, I'll get R is equal to lambda B plus A, or more formally, R is equal to A plus lambda B, right? Where A will be a point on the line and B is the direction vector. Are you okay with that? So that R represents any vector along that line. So technically what you have here, that there is the vector equation, that there is the vector equation of a line. Are you okay with that? R is equal to A plus lambda B. Yeah? Copy it down. Yes, yeah. Yes. Okay. Yeah, I hear something. Are you okay with that? So now we're going to use that vector equation. R is equal to A plus lambda B to obtain any equation. That's the general form. I think I'll do, I'll send any slides before, so you have all these notes and you can do more practicing, right? But I know some of you like your notes are flown up, so. I was supposed to do the revision class of module 1 this Saturday. But forget to model some with it. So I'll add it. That shall be the next week. I'll be like a couple hours I'll revise module 1. Is that it? Okay, it work out. But no, but using GeoGebra work. It didn't work for me. I just give them the equation. But you're doing something with straight on a curve. I use a cylinder, so it's easy. It's just a straight line on the curve. All right, so nice. So now that we know what the vector equation of a line looks like, this is the vector equation of a line. The general form, as I just showed you, is R is equal to A plus lambda B. Right? Now we're going to learn about the Cartesian form and the parametric form. Right? So let's say I gave you A. Right? I'm going to use numbers for it to look easier, right? So let's say I gave you the vector A. Let's say A is 2, 1, 3. And let's say I gave you the vector B. B is 1, 0, minus 3. Right? Let's see if we could go from the vector equation to all the others, right? So watch this here. All right. So let's start, right? So first thing first, let's start with the vector equation of the line. So R is equal to A is 2, 1, 3 plus lambda by B, 1, 0 minus 3. That's it. Nothing else to do. Are you okay with that? That is easy enough, right? Now, let's see if we can move on from there and get the parametric form. So remember, I told you R is any point along the line, right? Or any vector along the line. So R is X, Y, or Z, anything along the line. So X, Y, or Z is equal to 2, 1, 3 plus, let's multiply everything there by lambda. So we'll get lambda 0 minus 3 lambda, right? Let's add the two vectors on the right-hand side, and you'll end up with 2 plus lambda, 1 plus 0, well, that's 1, and 3 minus 3 lambda. Are you okay with that? What you recognize there? What that's saying is X is equal to 2 plus lambda, Y is equal to 1, and Z is equal to 3 minus 3 lambda. This is called your parametric form, right? X, Y, and Z in terms of lambda. Are you okay with that? I'll show you Cartesian one time. Cartesian is just to make lambda the subject of the formula now, right? So if I make lambda the subject in the first one, I will get X minus 2. If I make lambda in the second equation, well, there's no lambda, right? And in the last one, if I make lambda the subject of the formula, I will get 3 minus Z all over 3. So therefore, since this is lambda and this is lambda, your equation is X minus 2 is 3 minus Z over 3. There is no Y, right? There's no part with Y. And that's it. This last form here is your Cartesian. Cartesian is only X, Y, and Z. Parametric has lambda in it. Vector has I, J, and K in it. Are you okay with that? So take a little look. There's the example, isn't it? Note. Go ahead. You don't copy down already. Right, but that's basically how you go from one form to the next. Go over the Cartesian form, sure. So to get the Cartesian form, all you're doing is you're making lambda the subject of, the formula in each one. So lambda here is X minus 2. That's how I got that. There is no lambda in equation in its second part, so that part is 0. Right? And the third part, you make lambda the subject, and you'll get 3 minus Z on 3. So now that you know lambda is X minus 2, lambda is 3 minus Z on 3, then we can equate them, and you will get this equation here. That is called a Cartesian. That's okay? I'll show you our next one. Right? Well, this here's the notes I wanted, right? Very still right, you know? I remember if you miss anything, you could always watch back the video, right? There's some of views and thing. You watch it twice or 3 times. All right, so all right, so generally, this here, so generally, if R is equal to Xi plus Y, J, and Z, right? This here is how you can write it in your Cartesian form, right? That's generally how you get the Cartesian form. Right? You'll notice in the Cartesian form, these 3 values represent A, these 3 values here represent B. That's okay? And then you have a Cartesian form, and then you could convert it by making lambda the subject. So yeah, sorry, that was your parametric form. By making lambda the subject, you can convert it into your Cartesian form. That's okay? So that's generally what you do. So let's give it a little try here. Y'all see enough? A is 2, 1 minus 3 is parallel to 2i j minus k. Write it in all 3 forms. Try it in the vector form, Cartesian form, parametric form. Parametric, then Cartesian, sorry. If you lost a comment, I'll help you. Take your time, right? Two, 1 minus 3, 2i plus j minus k. Right, try to do this now. Right, so put it in vector form. Right, just write it like the equation or Right. Right. Let's check it out and see. All right, so that's the vector equation there, right? 2, 1 minus 3 plus lambda 2, 1 minus 1. Always remember the point on the line is A, right? Well, that'll help you get A, and the vector parallel is B. So R is X, Y, Z. 2, 1 minus 3. Multiply everything by lambda. 2 lambda, lambda minus lambda. That's okay? Then X, Y, Z is equal to 2 plus 2 lambda, 1 plus lambda, minus 3 minus lambda. Are you okay with that? So therefore, your parametric is X is equal to 2 plus 2 lambda, Y is equal to 1 plus lambda, and Z is equal to minus 3 minus lambda. Right? Sorry. Now you can make, now we're just going to make lambda the subject, right? You okay with that? That there's a parametric X, Y, and Z in terms of lambda. Now we're going to make lambda the subject in each one. So in the first one, I'm going to do all the steps. So X is equal to 2 plus 2 lambda. 2 lambda is X minus 2. Lambda is X minus 2 on 2. Right? And next one, lambda is 1, Y minus 1. And here, lambda is equal to minus 3 minus Z. So all we have to do is equate equation 1, 2, and 3. So 1 is equal to 2 is equal to 3. X minus 2 and 2 is Y minus 1 is minus 3 minus Z. Check it out. Any questions? Any questions online there? Oh, look. Say that again. The Cartesian form doesn't have lambda. No, the last example that we did had no second term, had no Y term. Right? It had no Y term in that. Right? Trouble? Trouble? So for the Cartesian form, for the Cartesian form, you just make lambda the subject and equate. That's it. You leave it right in. So you equate and leave it right in. All right, so let's just take one more. Anybody write it? Let's take one more. You'll see now. It is parallel to 3i minus 4j, and it is passes through the point I minus 3j plus k. So I kind of help you with the vector form already. Sorry. Right? You have the vector form. I just want the Cartesian and the parametric. Iris again, true. Koi again, true. Yeah. Okay. Right. So you're taking that vector form there and it converting it into both forms, right? After a while, you see how fast it is. Try that. I'll give you one more and we'll finish the group. I'll give you a form and you have to get it. Nice. Right, so I will show you this one, and I'm going to give you our next solution. We have the video card solution, and you have to do everything else. Right. Then the next thing we have to do is be able to solve them. So we have to check lines and check and see if the lines are parallel, if they intersect, or if there's Q. Right? And that's what you have to know about the equation of a line. Yeah. So let's check this. Let's check this one out. The vector R is equal to 1 minus 3, 1 lambda by 3 minus 4, 1, right? Right. Some people use different variables like mu and thing, right? I just use lambda for the variable here, for the constant here. All right. So R is equal to 1 plus 3 lambda minus 3 minus 4 lambda, 1 plus lambda. Right? Please remember that R is really X, Y, and Z. So X is 1 plus 3 lambda. Y is minus 3 minus 4 lambda. Z is 1 plus lambda. And then from right here, we can make lambda the subject. Lambda is equal to X minus 1 on 3. Here, we'll get lambda is equal to Y plus 3 over minus 4. Here, we'll get lambda is equal to Z minus 1. Right? You can't leave it like that. What we have to do now is just equate all the lambdas. So you'll get X minus 1 over 3 is Y plus 3 over minus 4 is equal to Z minus 1. That's okay? That's all you're doing. Right? All right, I'm doing the wrong thing. All together? 1 minus 3, 1. 3 minus 4, 1. Yeah, and it was 1 minus 3, 1. Right, so the point was 1 minus 3, 1. And the parallel vector was 3 minus 4, 1. Yeah? What do wrong there? Or you make a mistake and put the direction vector in the wrong place. Yeah? Anybody else got this here? You got this? Also, so very see, look at the wording, right? Huh? Oh, I'm gonna show you. If you look here, right? What is, remember the vector form? R is equal to A plus lambda B. A is the point on the line, and the next one is the direction vector, right? So if you look at the wording here, given that the vector equation of the line is parallel to 3i minus 4j plus k, what does that mean? It means that 3i minus 4j plus k is the parallel vector, which is p, right? Which is here. Right? Remember, R is equal to A plus lambda B. This here is your direction vector. The direction vector is the one that's parallel to the line. That's okay? And then the point on the line is A. Right? 1 minus 3i. Are you okay with that? You understand the difference, right? This here is always the parallel vector. We call it the direction vector, right? And A is always the point on the line. All right, any questions online? Just in case you wanted to work in, right? Any questions online there? Zaria, are you okay? Zachary? All right, so that's the vector equation of a line. Right, so here's what I'm going to do now. I am going to give you a Cartesian, right? And I want you to reach up to here. So you're doing the reverse. Make it equal to lambda, right? It will look like this. And then make X the subject, make Y the subject, make Z the subject. And then put it like this. And then separate it up into this form. Right? So you're going in reverse, right? You're taking the Cartesian, you're making each one equal to lambda, then you're making X, Y, and Z subject. Then you're putting it in this form and then you're splitting it up to the one on top. Now I'm going to give you the next one. Right? So you're going in reverse. I'm going to explain it again, right? So you're going to start right here. And you're going to equate each one of them to lambda. So it will look like this. Right? Then you're making X the subject here, X the subject here, Z the subject here. And then you will end up with your parametric form. From your parametric form, you're writing it like this. Right? And then you're going to split it up into the vector form. That's okay? So we're going to reverse now. Right? Let's try one. Try this here. Go in reverse, right? That's the Cartesian equation of the line. X plus 1 on 3, Y minus 2 and minus 5, and Z is minus 1 and 4. Take your time, try it out. And just go in and give it, right? Give it a back. All right, so watch here. So if you look here, right? If you look here, this is the Cartesian, and we're going to go to the parametric form. Take a look and see. Right? So you'll get lambda is x plus 1 on 3, right? You'll also get lambda is equal to y minus 2 all over minus 5, and you'll get lambda is equal to c minus 1 on 4. Okay with that? So from here, because you want to get it parametric, you want to get make x is subject, right? So x is equal to 3 by lambda minus 1. Like you write it the other way around. Right? You'll get minus 1 plus 3 lambda. Here, you make y the subject. So you will get 2 minus 5 lambda. Here you make z subject, and you will end up with 1 plus 4 lambda. Are you get that? Right? So this is your, not this, this is your parametric form. Right? Are you okay with that? Next step. Next step is to write x, y, z. Right? Is equal to this plus this. So that's minus 1 plus 3 lambda, 2 minus 5 lambda, 1 plus 4 lambda. Are you okay with that? So this is your R. This here is a point minus 1, 2, 1. Constant is lambda, and your parallel vector is 3 minus 5, 4. That's okay? Vector, parametric, Cartesian. That's okay? Everybody okay with that? Any questions online? Any questions online there? Nathaniel, you okay with that? All right. Okay, so good. So that's the easy part, right? Now we want to learn a few other things about these vectors, right? Somebody asked, so can you just restate which is which? This is your Cartesian. Cartesian has no lambda in it. This is your parametric, x, y, z in terms of lambda as a parametric. And then here is your vector form. Are you okay with that? Nice. So we need to learn some other things about lines, right? Taking this up, right? Everybody have that? Good. We need to learn some other things about lines. Right, I'll try to draw it here for you in a diagram, right? So remember, everything is 3-dimensional, right? So the first thing that we can identify about lines, we can identify if the lines are parallel. Right? I'll tell you how it tests now, right? So the first thing we can identify is if these lines are parallel. right? I'll say that's not how. The next thing is that we can check and see if the lines intersect. Right? So lines could be parallel. Of course, they won't intersect, right? Lines could intersect. And the last thing is that these lines could not be parallel and do not intersect. So for example, if you have a vector here, right? This is 3-dimensional, right? So if you have a vector here and a vector here, would these two ever meet? What these lines? Would they ever meet? They're not parallel, they don't intersect. So these two lines will never meet. If I draw this line all the way and I draw this line all the way, they will not meet. Those lines are said to be skewed. Okay? So if I have a line here going like that, and a next line going like, remember it's 3-dimensional, right? And you have a next line going like this, those lines may never meet. Right? Remember it's 3-dimensional. So this acting on that plane, and I have a next one acting on this plane, those two lines will never meet. All right, remember it's 3-dimensional. Okay? And they are not parallel either. These lines are said to be W's. No, Nathaniel, they wouldn't meet at the origin either. They wouldn't meet at all. If they're skewed, this one, let me draw it a little slack, a little bit, right? So yeah, I don't want it to look like it, they will ever meet. Right? They would never meet. And they're not parallel as well. Okay, so we're going to talk about how are we going to know if two lines are parallel? How are we going to know if they intersect? All right. Ready? So good. How do we know if two vectors are parallel? Right? Any ideas? Suppose I gave you these two vectors and I told that these two vectors are parallel. Or check and see if they're parallel. What you could do? What you could do here? Of course, I'll give you values, right? Any ideas? Huh? Right? See if these vectors are multiples of each other, right? So you're checking the direction vectors. Okay? So you're checking B and D, and if they are multiples of each other, then they're parallel. So if they're parallel, they will not intersect and they are not skewed. That's okay? But suppose now they are not multiples of each other, then they're not parallel. How you will show if they intersect? Well, what you're going to do is solve these two simultaneously, right? You solve these two simultaneously and you check and see if they have anything common. If you get a point in common, then they intersect. But if they don't intersect, then they are skewed. So write this, and I'm gonna give you a small note. Got it already? All right, take this small note. A to determine if the lines are parallel. To determine if the lines are parallel. To determine if the lines are parallel. Check the direction vectors of both lines. Check the direction vectors of both lines. Check the direction vector of both lines. And determine if they are multiples of each other. And determine if they are multiples of each other. And determine if they are multiples of each other. Right? B. Solve both lines simultaneously. B. Solve both lines simultaneously. Solve both lines simultaneously and determine if they have a point in common. And determine if they have a point in common. And determine if they have a point in common. And C. And C. And C. Last one. If they are not parallel, and they do not intersect, if they are not parallel and do not intersect, then they are said to be skewed. Then they are said to be skewed. I've copied this down and I want to show you what to do, right? Right? Ready? Ready? So I'm going to show you what to do, right? So step number one. So the first thing that we're going to do, we want to determine if it's queued, right? So step number one, we're going to check to see if parallel. So we're going to check if parallel. Right? So we're using the direction vectors here. So L1, the direction vector is -3, 1, -5. For L2, the direction vector is 5, -1, 4. Can I multiply this together? Can I multiply anything by this together? No. So therefore, they are not parallel. Right? That's step number one. Step number two, we're going to check to see, check if they intersect. Right? So the first thing we're going to do to check and see if they intersect, we're going to put them in the Cartesian form. Right? So I'm going to put this in the Cartesian form. So L1, right? You'll see in there, right? L1 is what? X is equal to -2 -3 lambda. Y is equal to 1 plus lambda. And Z is -5 -5 lambda. Right? That's L1. L2 now. L2, right, is -3 plus 5 mu. Right? So X is equal to -3 plus 5 mu. Y is equal to 2 minus mu. And Z is equal to -11 plus 4 mu. All right. So that is your step number two. Put them in this form. Take it in first, now write it down after. I want to make sure you understand what to do. So I take it from vector form and I put it in parametric form. Okay? Right? I'm going to put it in parametric form. Now, I am trying to see if these two intersect. So if they intersect, then X should be equal to X, Y should be equal to Y, and Z should be equal to Z, right? If they intersect. Because it means that they should carry the same point, right? So I can equate. I am going to equate the X values. So -2 -3 lambda is equal to -3 plus 5 mu. So if they intersect, then there should be a value for lambda and a value for mu that will make this equal. That's okay? If they intersect, right? So we can make lambda the sub. Actually, let's do the next one. And 1 plus lambda, that's the Y here, is equal to this here. 1 plus lambda is equal to 2 minus mu. Right? If you look closely, it's two equations you have to solve simultaneously. Right? It's up to you. You can multiply everything by, you can multiply this equation by 3. Right? And you will get 3 plus 3 lambda is equal to 6 minus 3 mu. It's up to you, right? You can make lambda the subject and put it in there. Anything you want. So I multiply this by 3 and I get this. So I have an equation here. Let's call this 1. Let's call this 2. Right? So I'm going to have -3 and I have plus. So I'm going to add equation 1 and 2. Right? So -2 plus 3, that's 1. -3 plus 3, that's 0. -3 plus 6, that's 3. 5 plus -3 is 2. Now, yeah, I'll do that last. Right? Remember, I have two unknowns. So I just need two equations, right? I'll show you. I'll use Z in a little while. So I can rearrange this, and mu is what? What would mu be? 1 minus 3 all over 2. So that'll be -1. Yeah? Mu is -1. Okay? So therefore, lambda is what? Just taking one of the equations, right? So therefore, 1 plus lambda is equal to 2 minus -1. Lambda is equal to 3 minus 1, which is 2. Right? So here's what we have. We have lambda is 2. We have lambda is 2, mu is minus 1. All okay? You're almost done. Last step. So for L1, Z is equal to minus 5 minus 5 minus 5 lambda. So that's minus 5 by 2. So that's minus 5 minus 10 minus 15. So L1 is Z is 15. Let's check L2 now. L2 is what? L2 for Z is minus 11 plus 4 mu. So that's minus 11 plus 4 by mu. Mu is minus 1. So I get in Z. I get in Z to be minus 50. Are they consistent? Are they the same? Right? So therefore, L1 and L2 intersect. Right? Since the Z's are consistent. That's okay? So because these are the same, we got to go. All right? Copy it down. I'm going to explain it again for those who may have gotten lost. It's a little long, right? It's a little long. This is carrying 8 marks already. Right? It's easy 8 marks. Right? Right? For those who get a little lost, I'm just going it over. I want to show that these are skewed also. By the way, are they skewed? Are they skewed? No, they are not skewed. They intersect. Right? So step number 1 is to check and see if they are parallel. So I compare these two. They are not multiple, so they're not parallel. Check and see if they intersect now. Take this and put it in the parametric form. When you put it in the parametric form, equate the x, equate the y. And you'll get 2 equations that you solve simultaneously. When you get mu and lambda, put lambda in here, put mu in here. Check and see if these values are the same. If they are the same, they intersect. If they are not the same, they do not intersect. Online, are you okay with that? Oh, daytime already. Come on, we can do one. Just squeeze in one. All right, copy it down. So that's an example of how to prove if lines are skewed or not, right? I'm giving it 1 and that's it. So that is a 1 or come on, handwriting was good there, Shabani. So that's a L or 1 at the first line on the right. That's a 1. Right? That's a 1. Right? I use this equation here and I solve for lambda. Copy it down and let's see if we can just squeeze in 1 and we're done. Are you okay with us? It's a little long, but it's simple, right? Suppose it is simple, right? Right? In case the question asks for the point of intersection, right? You plug in lambda here, here, and here, and you'll get x, y, and z. Right? I only found z. Right? But if you put lambda here, you'll get x, y, and z. If you put mu here, you'll get the same thing. All right? But I only found z. All right, last one, and that's it. It's from a textbook, right? So determine if this is skewed, and that's it. Shouldn't take you long. Right, so let's change the values around. Determine if skewed. Right, so to those who are online, just message yes or no. If it's skewed, message yes. If it's not skewed, message no. Change the number, right? So let's squeeze in one for we people finish already. Come on, finish already, are we? See what it is, right? All right, so say what it is, right? Might catch a few people. Okay, real fast when I finish already. Right, those who online, just message skewed or not skewed. Right, and it can be specific, right? Go on. Right, what again? All right, so if you look here, right? If you look here, what you'll recognize. This is a multiple of this, this is a multiple of this, right? If you multiply this by 3, you'll get this. So therefore it is parallel, right? So once you say it parallel, you're done. That's it. So it's parallel, so it's not skewed. This would be a 2-mark question. Right? You might have seen that more like a multiple choice. So it's not skewed. Right? Parallel, right? Next day I'll give you one. We have to do it in full. Actually, right, if you want, you can try it. It's homework, it's homework. It's up to you. I like what I will do it in number. All right, I'll send it in the group. I'm not seeing it in this year. Right, I think it's 2018, I think 2017 or 2018. Number 4. How is it parallel? Because if you multiply this by 3, right? If you multiply this direction vector by 3, you'll get 6 minus 3, 9. Right? So that's why it's parallel. Right? You're only interested in the direction vectors, right? Not the point on the line, but the vector on the line. All right? All right, online. So